All right, good morning. It's Tuesday, May 19th. This is E-Period Algebra 1. It's our next to our last class of the year. Let me go over some announcements,
We
and
know.
I'll take some questions. If you just, I may answer your questions here in my discussions. Thursday is the last day of class, and Thursday is the last day to submit any late work of any kind. Hopefully, you've been following along in Blackbaud and caught up on any missing assignments, but this is the last 2 days to take advantage of that opportunity. You may have an M in there from stuff that you believe that you submitted. Maybe you actually did, but it doesn't have a name on it. So if I can't recognize a handwriting, I can't just arbitrarily assign it to you. So follow up behind me. Thursday is absolutely the last, no ifs, ands, or buts, of missing assignments. Along those lines, and I'm thoroughly confused as to why, since this was mentioned to you on last Thursday, the 13th, I believe it was. But the quiz from last Tuesday on section 6.2, I did not receive a quiz from Mr. Campbell, Mr. Clark, Mr. Gilmartin, Mr. Seeley, and Mr. Martin. It's not in Dropbox, and I did a word search on emails. So I don't know what the heck you're doing, but it was due before class last Thursday. I mentioned these names back then, and you still didn't submit it. So if you want to get partial credit for a quiz, which is more valuable than classwork, homework, you better get it to me today. I'm not even going to take that tomorrow. Today is the last day for this quiz. It was due almost a week ago. All right, Mr. Martin's got a burning question.
On the quiz,
Bro, Mr. Gaffney.
there could be no late submissions. So I just stopped doing it.
So you just threw in the towel.
Mr. Gaffney.
I didn't know if we could turn it in still.
Here's an opportunity I'm giving you an opportunity to turn it in.
Yes, sir.
You're welcome.
Mr. Gaffney.
All right, Mr. Hunter, now that you've talked over everybody, go ahead with your question.
Can I ask you a question?
You just asked one, so now you may ask your second.
All right, my bad. Why haven't you put in my homework grade? I'm still sitting at an 88. And it says my participation grade sucks.
Yeah, well,
Oh, wait, never mind.
this class on Tuesday last week, so you lost 45 points. And as I've mentioned several times, if you miss a class, you can go back and watch the YouTube of the class, write a 5 to 8 sentence summary of what happened in class, and that will give you most of those 45 points back.
Oh, wait, what?
So you were absent. I'm answering your question, Mr. Hunter. If you wouldn't talk over me so I don't have to mute you. You missed class on Tuesday. You were late on Thursday, so you have points there. The previous week, you were late on Tuesday. You didn't make it to Thursday. Let's see, the previous week, you were here there both days. Previous week, you were tardy one of the 2 days, and you lost points there. So, I mean,
Okay.
if you come into class late, if you're more than 90 seconds late to class, I'm not even supposed to allow you in. So you're welcome.
That's a minute and 30 seconds. That's wild.
Yeah, it's wild. It's totally rigorous and demanding. All right, any other intelligent questions? Mr. Seeley, did you drop off? It looks like it. Let's see. We lost Mr. Gilmartin. Why is everybody dropping off?
Mr. Gaffney, can I stay back after class and ask you a question?
Yes, sir. Or you can come. I still do office hours every day from 2 to 2:30. Every day from 2 to 2:30. Okay.
All right.
You can hang on after class. Other questions? All right, let me mark the people that came into class and now have since left. Let's see, Gilmartin.
Mr. Gaffney.
Left, Seeley, left. Yes, sir.
So I guess I see on Blackboard it says last graded student work for today, and it says rep grade from 5:15. It's a 55. So can I get that up like Hunter is and do a 5 to 7 sentence summary?
I mean, been the policy since part of this 6, 7, 8 weeks ago.
Oh,
Somebody
okay.
happened to Mr. Campbell and Mr. Davidson. They've dropped off the map also. All right, we're down to the bare minimums. Okay. Check your paperwork in front of you. I've got some confusion in my Blackboard notes. On Thursday, we were doing section 6.3, solving systems equations using elimination. And I think we did, refresh my memory, we did problem set 1 in class and problem set 2 was homework. Is that correct? Or do you have something different?
Yeah, I think we did like maybe the first 3 and then a couple of the word problems, I think.
Which problem set?
6-3 number 1, because I remember we did the Rima and Ken one.
Did we do 6.3? Did we start 6.3 number 2?
I mean, I have it done, so
6.3 number 2? Chris, Joe,
yes, sir.
Mr. Hughes, do you have 6.3 number 2 in front of you there? Anybody?
No, I don't.
Chris, you don't? Mr. Clark, do you? Did you do it? How about Mr. Kelly or Mr. Hughes? 6.3 number 2. I had actually prepped that one to go over today. You have 6.3 number 2 there in front of you? And have you done many of the problems?
I'm happy to learn about it.
Okay, well, it's 6.3 number 2 is a lot like number 1. I had just prepped I was looking over my Blackboard notes and then the way I had written it up, and I just wanted to make sure I'm doing what we said we're going to do, is I prep problem set number 2 for today. Mr. Kelly, are you there?
Didn't we already do problem set number 2?
That's what I thought you were supposed to do over the 5.
Yeah, we're supposed to do. We're supposed to finish the problem set 1 and 2.
That's what I had written in Blackboard. Okay, with that being said, I'm going to put problem set 2, the answer key on here, go over a few kind of refreshers and reminders, answer any questions, make sure we've got a pretty good understanding of that section. Mr. Kelly, are you there? Or are we just looking at your ceiling fan spinning around? All right, with that being said, let's see. Give me a second to kind of fire this thing up and see if I can get it enlarged.
People actually shop at TJ Maxx.
Okay, so we're solving systems of equation using elimination. Remember 6.3 or 6-2, we're using substitution. Both of these methods both are used to solve systems of equations, meaning we got to find out one of 3 things about those lines. Do they intersect, where they cross over each other and they have 1 point in common, which is going to be the situation probably 80+% of the time. Or are they parallel and they have no points in common? Or are they the exact same line and they've got infinite points in common? In section 6.2, we learned substitution, where we substituted something for something, so that we had we took the 2 equations, boiled it down to 1 equation with 1 variable and solved for that variable, then went back in and took that variable and plugged it into either of the 2 original equations to get the missing variable. That was substitution. Now we're going to use elimination. And the nice thing about these names is the names tell you what you're going to do. All right. So we're going to eliminate one of the 2 variables using and create a smaller equation with 1 variable and solve for it. And then once again, go back and plug that that solved variable into either one of the two original equations to solve for. So these here, and I think I probably did number 1 in class, but looking at number 2, when we've got, let's see, let me get this. When we've got we got two variables with the exact same coefficients, that's what we're going to go after and eliminate. And I think all the subtraction to eliminate one of the two variables. So 3m minus 3m canceled that out. A negative 4n minus 2n left a negative 6n. And negative 14 minus a negative 2 is the same as a negative 14 plus 2. So now we're down to negative 6n equals negative 12 that we boiled down from these two equations. And then we just solve for n. We get n equals 2, all right? And so we took this 2 here and plugged it in for this m here in the first equation. You can use either equation, so we now have 3m minus 8 equals negative 14. We added 8 to both sides, so then we have 3m equals negative 6. We divided both sides by 3, and we get m equals negative 2. Is that negative 2? Yeah. There should be a negative right there. Is that right? Yeah. Should be a negative right here. All right. Here we went after the b's because the b's have the exact same coefficient of 1, and we subtracted to eliminate that. Just looking at those first 3 and the answers, hopefully you've got your answer sheet there in front of you and that you've got these answers. Is there anything I need to clarify or reiterate so that this makes sense to you? Mr. Martin.
So on 4n minus 2n, how did you get 6n? Because 4n is a negative?
All right, so it's negative 4n minus 2n. So if you think of it in terms of a number line, if I'm at negative 4 and I take 2 more away from it, I got negative 6, right? Think in terms of a number line. Right, so it's negative 4 minus a positive 2.
Okay, then that's where I messed up. Now I
You got
know
it?
that.
Yeah, you make sure you're doing that correctly, because otherwise you're going to get the wrong answer almost all the time.
So if there's a negative sign, like over here on number 1 where it's 5y negative, it would be negative 7, right?
All right, so that's why I put these out in front of it, so that we're subtracting that bottom equation from the top equation, right? So it's 5y minus a negative 7y. So I've got the double negative, right? So 2 negatives or a double negative makes a positive, so it's 5y plus 7y, right? Double negatives. Double negatives always make a positive. You know, put that into your repertoire of doing these, all right, so that you know, so that you always do that. Because if you don't, that's a basic property of adding and subtracting. And if you're doing it incorrectly, it's going to cause a multitude of problems and a multitude of situations.
Okay, so a negative minus a negative is a positive.
Well, when I have consecutive negatives, let's look at this, the one you just asked at. I've got a positive 5y minus a negative 7y. So I got a back-to-back or consecutive negatives.
So it's really plus 7.
Negatives makes a positive, so it's plus 7y. Let's look at this one. I've got negative 4n minus a positive 2n, so that's negative 6n. Here I got positive b minus b. This negative means I'm subtracting this a from 3a. I'm subtracting this b from b. I'm subtracting this 3 from 1, right? So 3a minus a is 2a. B minus b zeroes out or cancels out. And 1 minus 3 is a negative 2. Again, if you think in terms of number line, I got 0 here and I got 1 here. And I subtract 3 from it. I'm going to the left, right? So 0 is 1 from it, -1 is 2 from it, and -2 is 3 from it. All right, think in terms of just a basic simple number line. So we went from here to here. All right, make sense? Does that clear up some of the confusion?
Yes, sir.
All right, let's look at side 2. See if I can, let's see, I'll just do 2. All right, so look at 4, 5, 6, well, 4 through 9, all right? And look at my work versus your work and check to see if the answers mesh up. And while you're doing that, Mr. Campbell, I see you joined late, and I appreciate that. I don't have a 6-2 quiz from you that was due last Thursday.
I think I did that. Is it in the Dropbox?
No, sir. There's only 3 people that submitted it in Dropbox.
All right, I'll go check. Do you want it in the email or Dropbox?
Email. And then for Thursday, if you want to join class, you need to be in within the first 90 seconds of the start of class. Otherwise, I'm not supposed to let you in.
Sorry.
Okay, let's see. Let's just, anybody want me to pick out one of these? Want to pick out one of these, and I'll walk you through it, or just talk about which one? 4. Okay. So once again, we're subtracting that bottom equation from the top, all right, which is going to eliminate our x's, right? So I've got a -3x minus a -3x, so that's a -3x plus 3x, so those zero out, right? I've got a -4y minus y, which equals -5y, and I've got a -23 minus 2, which equals a -25. Didn't show the interim step, but here I just divided both sides by a -5, which now makes that left side of the equation y, and -25 divided by -5 is a +5. All right, so I've got 1/2 of the ordered pair. Right? I take that +5, and let's see, I plugged it into the second equation. The reason I did that, I used this equation, you can use either one, is that I didn't have to multiply it by 4, so it kind of saved me a step. All right. So taking that second equation and replacing the y with 5, I've got that. I subtracted 5 from both sides, so it zeroed the 5 out on the left and made the 2 on the right a -3. And then we divided both sides by -3, and we get x equals 1. Giving us the ordered pair of 1 and 5. Questions on that? All right. Again, take a look at 5, 6, 7, 8, 9. See if there's any dispute, discussion, debate, or anything you want to clear up or address on any of those 5. Are we getting these answers? Mr. Clark says yes. Mr. Martin says kind of, maybe, sort of. Mr. Hughes is resting. Mr. Kelly's ceiling fan is spinning around. I can see Chris's top of his head. Hunter doesn't have his camera on. Mr. Campbell, I can see the top of his head.
My bad, Mr. Gaffney. I'm about to turn my camera on right now.
Okay, I'm going to scroll up if we don't have any discussion on 5 through 9. Each one of those 6 are done that are on the screen in front of you right now are done using this exact same methodologies. Any discussion before I scroll up to the bottom ones or lower ones? Let me clear. Let's see.
Mr. Gaffney, can you go back up to number 6?
There it is.
Yeah, and scroll down a little. Hmm. Yeah, that's good. That's good, Mr. Gaffney.
Okay. All right, so there's 10 through 12 and the two word problems. Again, we just subtracted that lower equation from the top, eliminating either the x or the y initially, and solving for the remaining variable. Once you solve for it, go back and plug that value into either one of the two equations. Doesn't matter which one. I'd pick the one that looks easiest and simplest. Let's make our lives easy as we can and solve. For the word problem, you had to create the two equations, all right? It says the sum of two numbers is 70. So did that right there, x plus y equals 70. Then it says one number is 10 more than twice the other number. So it says, so here is 10 more than twice the other number. So we've got two equations, and we had to move this 2y over to the other side, so we got them in kind of in standard form, which we now have here. And lo and behold, I got two positive x's, so I'm going to subtract like I did in the previous 12 problems, hopefully, which eliminated the x's, and I end up with 3y equals 60 and y equals 20. And then I plug in 20 to the first equation, and I get x equals 50. So there it is, 50 plus 20 equals 70, and 50 equals 10 plus 2 times 20, which is 10 plus 40. So all that checks. Similarly, in the second word problem, two angles are supplementary, and I didn't even know what that means, and Mr. Bombowski wasn't nearby, which means they equal 180 degrees. So you had to know what supplementary is, so I just Googled it on my phone. So that's one of the two equations, and then the other equation says the measure of one angle is 10 more than 3 times the other. That's kind of a mouthful, so I made an equation out of that. X equals 3y plus 10, which is kind of similar how we just did the one directly above it. All right, we had to move the 3y over to the other side, so I got two equations in standard form. We're going to subtract the lower from the upper, and we got 4y equals 170, so one of the angles is 42.5, right? And I just plug that into, let's see if I showed that. I just plug that into either one of the two equations. So the other angle is 137.5. If you add these two together, it does equal 180. Okay, questions on that? Anything I need to clear up before we move on to bigger and better things? Yes, no? Are we getting these answers before we move on? I don't want to leave you in the dust. Are we good? If I gave you 8 of these to do for a quiz with 2 bonus questions, can you do them by Thursday? Yes, no? Give me a thumbs up or unmute. Mr. Kelly says he's good to go. 8 of these. Mr. Clark says he's good to go. Mr. Martin says he's good to go. I guess Mr. Gilmartin in the white. Is there anybody not good to go? If I load 8 of these up after class today with 2 bonuses, that it has to be done by Thursday because Thursday's the last day for all work.
So that's our last assignment then?
That's our last day of class. We're gonna do some one more set of systems of equations here for the next 15 minutes using, that we're going to up the complexity a little bit using multiplication. We'll do some
Oh,
kind of challenge thing with that on Thursday in class. Is it everybody's good for elimination? You can do this. You do exactly what it says. You're going to eliminate a variable, and you're probably going to eliminate it using subtraction. Let me see something. Let me look at one other thing. Yeah. Oh, there's a good point. Let's look at. Let me go back. Let's see. Yeah, give me 1 second. Let me see.
Wait, sir, are you gonna make the 8 questions like optional?
What do you mean option?
Like, could you make them like for extra credit? Like, say like if we needed it, it'd be for extra credit, and it'd be optional if we didn't like.
Let me think about it. I'm right now on the surface. I'm a little reluctant to do that because when we do optional and people don't do them, you know the drill there, right? Okay, I'm getting ready to share screen again. All right, let's go back. I'm going to pull up problem set number 1, just to make sure we've got all the bugs worked out. I mean, it's 8 problems. You can do it. You can do one of these every 2 minutes. So in under 20 minutes, you can take the quiz. All right, let's look. This was problem set 1 from the same section. Okay, so I might throw a couple of these in. How do we do these differently? Let's look at I'm just arbitrarily picking this one. All right, so I've got your first thing you're going to always do is look for the variable that has the exact same coefficient. All right, so y and y have the exact same coefficient. Now, different from problem set 2, we've got opposite signs. One's a positive y, one's a negative y. So how do I eliminate that variable? If I got a positive 3 and a negative 3, how do I make those 0? I add them together, right? I add them, not subtract them. So if I add each one of these three kind of like units, 3x plus 2x is 5x, right? All right. And then if I add a positive y and negative y, that's like 1 plus a negative 1. That zeroes out. They just zeroed out, which is perfect. And I got 4 plus 6 is 10. Right? I divide both sides by 5, and I get x equals 2. All right. So now I can go back in and plug in 2 for the x in either one of those 2 equations. I'm going to pick the top one just because the y is positive. It saves me an interim step. So now I've got 6 plus y equals 4, right? If I subtract 6 from both sides, I get y equals negative 2. So my ordered pair is 2, negative 2. Make sure it's an ordered pair, so the x always comes first, the y always comes second. If they just say pair, if it didn't matter, it's ordered pair. It's always x first, y second. X is our horizontal movement, y is our vertical movement. So the only thing different from this on this problem set 1 that hopefully you did versus the problem set 2 that we just went over is each time we have a variable that has the exact same number, but one's a positive and one's a negative. So instead of adding to eliminate that particular variable, instead of subtracting to eliminate that particular variable, we're going to add, and it will zero that variable out. Does that make sense? Any confusion? Anything I can go over? Anybody know what happened to Mr. Seeley? Or did he just do the touch and go and take back off? Try to grab the points. If you talk to him today, you're sitting on your phone, he's texting you, just tell him he lost the 45 points not staying in class. Okay. So
It could be.
I'm going to tell you right off the top. I'm going to give you 5 that you add, or excuse me, 4 that you add and 4 that you subtract. Ooh, big surprise there to eliminate the variable. And then the two bonuses will probably be a word problem. So is everybody good to go? So we can get a minimum of 94 on each of these? Or not each of these, but on the quiz for our last quiz of the quarter? Yes? Last call for questions on this. All right. I see a couple thumbs up. Mr. Martin's daydreaming out the window. Mr. Hunter's turned his camera back off. Let's see what else we got.
I'm just ready for school to be over.
And Mr. Gardner's turned his camera off. Mr. Hughes, I'm looking at his bulletin board. Okay. All right. So one last section we're going to do. We're going to up the complexity.
Mr.
Yay,
Gaffney,
sir.
Thursday?
Huh?
Is the quiz Thursday?
I'm going to load the quiz up. Give me about 30 minutes after class is over. I have to make it. Don't even have it made. So give me about 30 minutes and it'll be up there, but it's due before class on Thursday, so I can wring your neck in class on Thursday if you haven't turned it in. Put it in the Dropbox. Okay? All right. All right, I'm going to up the complexity on you one more time. Just grab a pencil and paper. We've got 10 or 15 minutes. I'm going to introduce you to this. And the reason I'm harping on systems of equations is that standardized tests love systems of equations. Why? I don't know. The SATs, SATs, and ACTs all like them. I will load this on Blackboard so that you have it. We're going to do a couple at least numbers 1 and 2 today. Why don't you just write down 1, 2, and 3. It's not homework. The quiz is your homework, and then we'll finish this problem set up in class on Thursday. All right. So the name of this section is solving systems of equation using elimination and multiplication. All right, you got two examples there that you can use as a reference. I'm not going to walk through them because you can just use them at your leisure and convenience as a reference. All right, so let's look at these collectively. You might want to write these problems down, right? Let's write number 1 down. So look what we got here. I got 2 equations, but I don't have x's with my x's don't have exact same coefficients, and my y's don't have exact same coefficients, so I've got a problem. You know, if I add the 2 together, I don't eliminate the x's or the y's. If I subtract the 2 equations, I don't eliminate the x's and I don't eliminate the y's. So it says we got to use multiplication to solve this equation. All right. The easiest thing, there's many ways to solve these, many ways to solve these depending on what you multiply each or either equation by. Some involve more work, some involve less work. I'm going to try to give you some guidance and direction to do it with the least amount of work. Because if we do the least amount of work, you can do it quicker and faster, which is important on standardized tests. But also, if it involves the least amount of work, you're less likely to make careless error. So, to me, looking at these 2 equations, the most simplest thing is to multiply that bottom equation times 2. Then I will have 2 equations with 2x. So if I multiply the bottom equation times 2, and just bear with my chicken scratch, this becomes 2x. This becomes 4y, and this becomes 10. Everybody see what I did? And I could do that. It's the same equation. It's 2x plus 4y equals 10. Because if I divide that whole equation by 2, I'll be back to x plus 2y equals 5. As long as I multiply the entire equation by the same amount. Okay? All right, so now I've got 2 x's. So how do I eliminate the 2 x's? I do what? I'm going to subtract the bottom equation from the top. 2x minus 2x, that zeroes out, right? 3y minus 4y is negative y, right? 6 minus 10 is a negative 4. So I've got negative y equals negative 4, but we're solving for y, not negative y. So if we multiply or divide either one by a negative 1, we get y equals 4. All right, I'm halfway home. I've got one of the two ordered pairs. I know it's x equals something, comma, and y equals 4. All right, so now I'm going to go back and take either one of these two equations, and I'm going to solve for x. Well, I'm going to use the second equation because x is just plain old x. It doesn't have a coefficient of a larger number on it. It's just 1x. So now I'm going to go x, all right, plus 2 times 4. I'm going to substitute that y in that second equation for 4. So now I got x plus 8 equals, you have to kind of look through my writing. I went back to the original equation. You could have used your newly created one that you multiply by 2, but the numbers are larger and you're more likely to make a careless error. X plus 8 equals 5. All right, so I've got one last step to solve for x. I subtract 8 from both sides, and I get x equals negative 3. Okay. So
How did you get 5?
because I'm using this original equation before I multiplied it times 2, which the original equation was, if you look through my handwriting there, is x plus 2y equals 5. X plus 2y equals 5 was the original equation, right? Does that make sense? Any other questions?
Oh, okay, I get it now.
Yeah,
Y
you have to
equals
kind of look
4,
through.
so you plugged in 4 for the y. 2 times 4 equals 8. Okay.
Correct. I just didn't write because of this pen and being pretty scratchy writing. I didn't write it.
Yes, sir.
I said it, but I didn't write it. All right. Other questions on that? Okay. All right. Let's talk through this one collectively. All right. So, which of the two variables would be easiest to eliminate? M or N? Anybody? We got a little.
Bueller.
sorry?
Bueller.
Thank you, Mr. Martin. Which of the two variables will be easiest to eliminate?
N. Or no. M.
M. All right, because if I go after the ends, I got to multiply this guy by 3, or excuse me, by 2, and I got to multiply this guy by 3, so I'd have 6n and 6n. All right, now I just doubled my work. If I multiply the bottom equation times 2, I will have two equations with 2 m's. All right, so let me do something here. All right, so I'm just going to take the first equation. Let's just simplify. So we got 2m plus 3n equals 4. Okay. All right, and then if I multiply the bottom equation times 2, I get negative 2m, bear with me, plus 4n equals 10, right? All right, so now, all right, so this is nice. I got two 2m's. I've got opposite signs. So how do I eliminate the m's? What arithmetic process am I going to use, or mathematical process am I going to use to eliminate the m's? Anybody? Come on, guys. What are you guys doing? Watching pants or something?
Subtraction.
Not paying attention? No, I'm going to add. I got a positive 2m and a negative 2m, right? If I add it, the m's cancel out. If
Yep.
I add the n's, I get 7n.
Then you got 7n equals 14.
And if I add 4 plus 10, I get 14. Right?
Yes, sir.
So now I got n equals 2, right? All right. So I got to plug that 2 into either one of the two equations. All right. So I'm going to use the second equation. So I got, and it doesn't matter which one, I got negative m plus 2 times 2 is 4 equals 5, right? All right. So if I subtract 4 from both sides, I get negative m equals, well, negative 9. No, equals, subtract 4, is that a positive 5 equals 1, right? And then I got m equals negative 1. We good? So now my ordered pair is comes before m. My ordered pair is negative 1, comma 2, right? Great. Now, if you remember our discussions last week, if I take this negative 1 and 2 and plug it in for the m and n here, and I plug it in for the m and n here, the math for this equation is going to add up to 4. The math for this left side of the second equation is going to add up to 5, right? And that is the ordered pair where those two lines intersect on if we were to graph them. All right, we got a few minutes remaining. I want you to copy down number 3, and I'm going to give you 2 minutes to solve it, and then I'm going to ask you some questions about how you did it. All right, you got 2 minutes to solve it. You don't want to look at your screen. It's 3a minus b equals 2, and a plus 2b equals 3. Now you're going to have to multiply one of those two equations by something. You got to first pick a variable to eliminate, and then figure out what I got to multiply one of the two equations by to eliminate that first variable. Go ahead and give it a shot. I'm going to give you 90 seconds now. Okay. There's two ways you got two options. I could eliminate the a's by multiplying the second equation times 3, right? I'd have 2 3a's. I could eliminate the b's by multiplying the first equation times 2, right? Those are your two options. Right? If I was doing it, I'd do this option here of multiplying the first equation times 2, because I'd have a negative 2b and a positive 2b to eliminate, which would be, which I would eliminate by adding, because I've got the same coefficient on opposite signs. If you have the same coefficient with opposite signs, you're going to add for them to zero out. If you have the same coefficient with the exact same sign, be it positive or negative, doesn't matter, you're going to have to subtract to eliminate that coefficient and variable. Okay? So real quickly, I'm going to do this because we're running out of time. So let's just, I'm going to do the first one. So now we have this, hopefully, if you did it the other way, that's fine, but we should get the same answer. So we'd have 6a minus 2b equals 4. All right? And then my second equation is A plus 2B equals 3, right? Now, I'm going to add the two equations because I've got a positive 2b and a negative 2b, all right? Add the two equations, I get 7a. That negative 2b and positive 2b zeros out equals 7, right? So my a equals 1, right? Everybody get a equals 1, hopefully? Now, the
I
second
didn't get that far.
The second equation looks simpler math to me, but you can pick either one. So now I've solved for B. I'm going to substitute that first A for 1. So I got 1 plus 2B equals 3, right? And if let's see, if I subtract 1 from both sides, I get 2B equals 2, right? Divide both sides by 2, I get B equals 1. So my ordered pair is 1 and 1. Everybody get that? So we'll pick up, I'm not even going to post, I will post this before class on Thursday, and we'll do side 2 for class on Thursday. Again, it's more complexity because you got an additional step of having to multiply to get a verbal with the exact same coefficients to eliminate. No, just an additional step, additional complexity. All right, so as a reminder, I'm going to load the 6-3 quiz up. There's going to be 8 questions. 4 you add, 4 you subtract. There'll be a word bonus problem, which will be, that'll be one of your bonuses. The other bonus is if you turn it in by 8 p.m. tomorrow night, as opposed to before on Thursday, you pick up an extra 5 points because that gives me a chance to score it before class on Thursday.
What's the homework, sir?
What I just said.
I didn't hear you at all.
No, boy.
No, because my computer keeps cutting out.
Take the quiz. It'll be loaded in about 30 minutes because I got to create it. 8 problems, 4 you add, 4 you subtract. One of the bonuses is a word problem. The other bonus is if you submit it by 8 p.m. on Wednesday night, so I can score it before Thursday class, you get an extra 5 points. That's the other bonus.
So are you talking about?
Go ahead, Mr. Hughes.
So are you talking about the quiz that was due last week, or
No, that's old news. That's history.
a new
No,
quiz?
that one's, that was 6-2. This is section 6-3.
Okay, and that's basically our homework, the quiz.
Correct.
Okay, thank you.
So it's
Yo,
does anybody
6-3.
know-
It's
what's
a
Miss
6-3
Rising?
quiz, right, Mr. Gaffney?
Yes, sir.
What's Miss Risenlever's office hours time?
Everybody's office hours 2 to 2:30. Hasn't changed in the last 7 weeks.
Oh.
All right, last questions. It's time to go.
Mr. Gaffney, so I'm gonna be
Yeah.
at my mother's house. I'm at my mom's house, and I need my dad to print out everything that I need. Can you tell me everything that we need to do this week, and email it to me?
Come on, I've got to go because I got to make the quiz. You can come on office hours. Talk.
All right,
Come on my office hours and we can talk.
Mr. Gaffney,
See you, Mr. Gaffney.
Yes, sir.
can you please send me like everything through email, like everything that I would need, because my Dropbox, because my Blackbot doesn't work too well.
Yep, I'll do it for all. I've only got 88 students to keep track of, but yeah, what the heck. All right, I've got to go. Bye.